Hi again. My name is Omer. I'm going to be going through how basically the solution works and how it's implemented. And the motivation basically is that a lot of the times when we used to explain the Granite technology to customers and partners, and oftentimes just evangelize about it, it used to create a lot of confusion in the field. Is it a block cache? What happens? Are you running iSCSI over the WAN? What's going on? Right.
So vouch for that. Yeah.
Right. So this is an attempt to basically clarify all of that stuff and just open up the covers to have people look inside of it and ask really deep questions as to what do we do at the file system level, what do we do at the block level, and how we integrate with different hypervisors. So it's generally an exercise in that. So the more interactive it is, the better it is for me. With me, I have Nitin, who's the VP of Engineering for SteelFusion. Has been working. He and I have been on this thing from nearly day one of its inception. With that, we have Chip, who's one of my lead architects who implements this in customer environments. And then we also have Gil, who's one of the most analytical minds that we have around, who basically tells me why is it not selling, or why is it selling, or what do customers want in terms of adoption and market penetration. Before I go into the depths of SteelFusion, formerly Granite, I'm going to give you some motivations as to why we developed this technology. Because a lot of the times, the most common question that I get from customers is, well, why can't I put like a baby FlexPod or a baby vBlock in a branch office and be just done with it, right? Why do I have to augment this with this kind of a converged infrastructure environment, right? So I'm going to start by giving you some motivations, some design principles that we started with, and then we're going to go into the technology and setting up this. What I've noticed in the past 2 years of selling this, setting up the context really helps the customer enablement in this new way of thinking. So one of the things that we're going to discuss today is consolidation with remote infrastructure, right? Typically, what we see is that these are two opposing challenges for every customer CIO that I talk to. Like local performance, I could not find an icon for a girl with eyes, so I just put that girl up there. It's no way meant that the girl is blind. She's using the infrastructure really well. So basically in remote offices, it's often driven by user experience-based consolidation, and these are opposing goals just because of the physics of the WAN in the middle, right? And the larger the distance, the larger the latency, and if you consolidate everything 100%, the CIO is often happy. Many organizations are fine with this model. Like in Korea, one end of the Korea to the other, the latency is literally 5 milliseconds, right? So they don't really care. For them, 100% consolidation, they're good to go. But typically, when you're dealing with customers like U.S. Army, Navy, federal agencies, customers like Eric mentioned, mining, these guys are very, very far away from the headquarters. So oftentimes, in order to give them user experience, you have to sort of push compute out there. Because at the end of the day, if you're computing closest to the end user, that's the best performance. The best user experience actually comes from the LAN, by computing on the LAN. But the problem with that is, the minute you push compute out there to give the user experience, and there are a lot of customers like that, like customers that produce a lot of revenue at branch locations. These are banks, these are insurance companies, HR agencies, legal firms, law firms that are scanning thousands of documents at one time. These are oftentimes retail chains that have inventory copies of databases local. When the WAN clips or a disaster happens, they still need to be able to serve customers. In order to give that user experience, you have to push infrastructure out there. Well, when compute goes out there to give the best possible user experience, the problem starts the minute you start to push storage out there, because storage and compute are tied together. That's what we have learned so far. The minute compute goes out there, storage drags behind it. The minute storage lands at a remote site, that's when you have to really make a decision, do I need to back it up or not, right? And the minute you start to back it up, you enter the picture of decentralized backup, or you start to worry about disaster recovery windows and replication, right? So, and at that point is when the dollars start to pump into your remote infrastructure. So that's sort of the thought process. Another thing it depends on is a lot of local I/O profiles in your branch offices. If your branch office workloads are random read-writes, if you're 100% consolidated and accessing your shares over the WAN, read-write which have random profiles or heavy write profiles, oftentimes you can't keep up with the WAN performance. And oftentimes we noticed that our Steelhead appliances did okay at the business of WAN optimization, but oftentimes the randomness of the workload was so high that we weren't able to keep up, and that's when the server went back out into the remote site, right? Another way to solve the problem is you could do VDI. And a lot of customers actually solve the problem with VDI. Okay, I'll put a VDI infrastructure solution back at the data center, fire up a bunch of desktops. Two problems, not actually a problem, two money-related problems come with that. First of all, you have to typically upgrade your storage based on a very high compute I/O workload back at the data center, so it costs money at the end of the day. And if the WAN goes down, whether you do VDI or if you are 100% consolidated, you're dead in the water at that point, right? So typically customers pay for another link to fall back on, or actually just end up pushing infrastructure out there, right? So the goal that I'm trying to define over here is that consolidation of remote infrastructure, if the stuff that you do at remote infrastructures is important, 99% of the time we have noticed that customers push infrastructure out there. The minute they push infrastructure out there, backup, recovery times, how long does it take to provision, how much money am I going to spend to refresh and maintain it, start to enter the picture, right? Idealized situation is consolidation because it's simpler. People just do business this way because that's just the way to do business these days, right? And especially if the WAN is down, there is no other way around it. So if I were to look at this problem from scratch, I mean, if I were to erase the whiteboard and look at it from the inception, right? If I were to define a remote infrastructure, I would try to sort of idealize it along three different axes, right? So number one, data. So no matter how remote my site is, I should be able to always be able to protect my data or consolidate my data. So if a WAN goes down, typically when I interview my customers, when we're selling a POC or a new solution out there, customers tell us, well, if the WAN clips and there's a disaster in my branch office, I typically lose about 8 hours worth of it. And that's very logical because you typically back up once a day. So if you lose sometime in the middle, and your backup job hasn't run, typically the loss is about 8 hours worth of data. If you want to protect it more, you got to spend more because a lot of remote solutions have snapshots and replication built into them. But snapshots require more storage at the end of the day. I mean, there are space efficient snapshots, absolutely, but you have to pay replication licenses, you have to invest more in snapshot storage, and you have to frequently replicate that back to the data center. So how to minimize the cost and still be able to consolidate and protect data without worrying about it, right? And the second vector is provision and recover. How quickly can I provision a branch office if I'm coming up from scratch? One of a common case of remote offices is law firms and insurance company. Typically, when I ask them how quickly can you provision a remote office, whatever servers, storage, whatever you want to do there, the answer I get is typically in addition, like in 20 days, 25 days, right? And if it goes down completely, closet burns down or some disaster happens, time to come back into business is typically high as well. And that is the opportunity cost to the business. But again, people don't complain about it because that's just the way to do business right now. Imagine I'm erasing the slate clean and try to idealize. So if I were to provision or if I were to make a solution from day one to figure out, okay, I'm not focused on converged infrastructures. I'm not focused on the problem of compute and storage. I'm focused on the problem of how to provision infrastructure across a WAN in the best possible way. The best possible way would be that there would be absolutely no data loss or close to no data loss, and I should be able to provision and recover in the matter of minutes without actually having to go out there. And the last part, because we often have customers that have remote infrastructure out at sea rigs. There are mining customers in the remotest parts of Australia being operated out of the Sydney headquarters. So typically the cost of shipping people there is pretty high. I mean, I've had Australian customers tell me that we get people off the street, all their job is to go there and plug cables, and they make close to $150K a year. Because it's the opportunity cost, and you have to pay them and motivate them to go in the middle of nowhere and just to plug wires, right? So it's a pretty, if you're into that lonely kind of gig, it's a pretty sweet gig. I mean, it generates a lot of money. So these are the vectors along which we will try to optimize. Close to minimum data loss, minutes to recover and provision, and the ability that you don't have to touch the equipment out there. And it should be stateless. Stateless basically means the same thing as, when you lose or when the infrastructure goes down, you don't lose anything because it's stateless, right? So so Riverbed has been has been in the business of minimizing the WAN latencies and at the same time being able to make customers productive around highly latent WANs. So one of the concepts that we have come up with is location independent computing. What that basically means is it is our job to give you, or we strive to give you, the best possible user experience no matter how far away you are from the data center. So now this is the slide where I'm going to lay down a couple of design principles, and then we're going to build into the solution from there, right? So if you look at the data center these days on the right side, or for you guys on the left side of the slide, presently there's a logical abstraction in the data center. It's very well known. You have a bank of servers, you have a bunch of storage, and then you have a DR protection policy, and hypervisors are running on your compute, and you have a storage environment, and you have logically separated your storage and compute at the end of the day. When you want to publish a service, it could be a file server, mail server, web server, you take a bunch of compute, you add a bunch of data stores and storage to it, attach a DR policy, and there you go, you got published a service, right? What we are trying to do is we're trying to separate the two out. Separation of storage and compute. That is the design principle behind SteelFusion, formerly known as Granite. So we're going to push the compute closest to the user, as close to the user as possible, possibly the branch office, because this is where the applications or the file server or the DNS server or the VDI desktop or a SQL database is going to execute. The virtual machine is going to execute. So you're going to get that LAN performance. But the storage is going to be pushed back into the data center because that's where it's simplest to deploy backup in a central location, right? How are we going to do that? This is what we're going to cover today, right? So another observation about this separation is that compute is stateless, storage is stateful, it's persistent. Why do I say that? Because if you lose your compute, you're not sad. You reboot the machine and you're 45 seconds, you're back into the same working set. If you're that paranoid about your virtual machine, you can snapshot running virtual machines and it can take you back to the same state. But if you lose your storage, you're out for days. You're out of business at that point. You got to recover from backup, and you better make sure that your backup policies are bulletproof, right? So at the end of the day, if I had to preserve something, I would preserve storage because that's persistent, right? And compute is stateless. Another concept I'm going to push over here. Everybody in this room has a smartphone, right? And this is the closest analogy that I can give to build on this concept. So when you check your email through the web browser of your phone, the experience is horrible. But when you check your email from the built-in native client of your phone, the experience is phenomenal, right? And that's what we call the location-independent computing, which is the inspiration of the solution today, right? Because see, when you're typing your email on the built-in local client, the email app is computing closest to you. But your mail server is somewhere in the cloud. Right? Same applies to almost every app that's running on your phone, because your phone is that disposable compute device that you hold in your hand for the best possible user experience. Anytime a new service is published, like Uber or any utility service is published, the first question that we ask these days is there an app for that? I really don't want to go on a website, right? Because you want that local experience. And when you're typing your email, you don't really care whether you're in 3G, Wi-Fi, Edge, or not even connected. You type the email, you hit send. Whenever you come into range, that email will go out, right? But when you lose your phone, you're sad for like 5 to 15 minutes, depending on what the situation of your wallet is, and then you go buy the latest phone again. You plug in a few credentials, you're back in business, right? Because that's the concept. The phone, if it's properly configured to the back-end cloud, and that can be your home PC, it could be your data center, web server, iCloud, Google servers. If you've configured it properly, that phone is completely stateless. You can literally lose your phone on the way to the airport, buy a new smartphone at the airport, plug in your credentials. Before boarding the plane, you'll be back in business, right? That is the concept we're trying to bring in to the concept of branch infrastructures. So that's what we're going to be building on.
But what happens if you lose the LAN, the one connection?
Yeah, that's what we're going to build on. So I gave you the example. Like, you don't really care when you're typing an email on the phone if the WAN is there or not.
It's a service disruption.
Yeah, it's a service disruption. From an experience perspective, you don't know. You hit send, and the minute you come into range, the email goes out, right? You don't have to manage that experience. That's what I'm trying to get.
If you have a database with
transactions, absolutely, yeah. Right? That's a corner case, and we're going to discuss that. Right, how we interact with that, right? That's a very good question. Right. So basically, that's the design principle, that's the thought process, that's the inspiration, so as to say, to bring the same level of flexibility, statelessness, and agility into provisioning remote offices and remote regional data centers.